All right, hi everyone. Welcome to my presentation. I'm Josh Chang, ML intern here at AI. And over the past week, I've been working on this automating the model leaderboard submission system. So traditionally, the model evaluation and leaderboard updates really rely heavily on manual form submission and backer interaction. And my role is to be replacing this process with a robust API powered system. This system is more than just a backend automation. It's a key step to make AI benchmark transparent, reproducible, and scalable. Through integration with the Blue and Bird score evaluation metrics, the leaderboard becomes a real-time resource for developers to track model performance across a growing set of datasets. And this talk will walk you through the old versus new process, the core APIs involved, and how we're enabling self-service submissions that feed directly into Ano's leaderboard platform. So let's dive in. Starting from a quick introduction of my role, I joined the evaluation leaderboard project to help streamline how models are added and evaluated. My main responsibility is to build the API backend that allows users to submit model through the UI. Once submitted, the system evaluates the models and automatically updates their ranking on the leaderboard. Beyond the API work, I've also been collaborating and working with others on the evaluation team for the logics and integration for the blue and the bird score metrics to make sure that they run smoothly behind the scene. And I'm working with the front-end team as well to connect these APIs to make sure that the submission can go well in the actual front end, which is currently static. And the presentation will be focused on submission pipeline and my contribution for building it. So, what is an evaluation leaderboard? In fact, it's a centralized platform for benchmarking AI models on a wide range of NLP tasks. It currently supports tasks like task classification, name entity recognition, and two forms of question answering. Document level like chatbot interaction, and line level such as prompt-based responses. By applying standardized metrics, the leaderboard promotes reportability, as mentioned, as well as transparency and a healthy competition among all different model developers. It also provides a growing public record of how different models perform across different datasets. Ultimately, the platform helps fulfill Ano's mission of making AI evaluation open, and accessible, as well as trustworthy. So before automation, submitting a model to a leaderboard was a really complicated manual process. User would fill out a Google form, like showing on the slide on the right, to upload their model prediction file, either in CSV or JSON format. And after that, someone on the team will manually evaluate the result, compute metrics like blue or bird scores, and then update the leaderboard themselves. This could create a bottleneck. Submission could take several days to appear, and what's worse is that there were room of error in manual handling. And most importantly, it's not scalable at all if the number of a model and dataset increase. And this is exactly the problem my project aims to solve. So now we're moving from manual Google form submission to a fully automated backend API pipeline. This system allows users to submit their model through a web interface, as shown on slide. The API accepts a dataset name, model name, submitter information, and the prediction file. It then runs evaluation using metrics mentioned previously and returns a score automatically. The score is saved and used to update a data board in the near real time. This API is a core piece I've been working on so far, and it replaces the slow manual process with something scalable and self-service. And this now I'll be illustrating how this end-to-end flow works for how to make models submit self-service without any additional help. So first, the user will upload their model to the user interface directly. This triggers a call to the add model to dataset API, which receives the input data. And then the backend will run evaluation logic, computing metrics like blue or bird score. The results are then stored in the MySQL database. And finally, the leaderboard frontend fetches the latest model result and display them to users. These all happen without requiring any manual updates, enabling near real-time feedback to contributors. While I've been working on the model submission API, My teammate Yining has also been focusing on creating an API for adding new benchmark dataset. That API lets users submit the dataset name, test type, and file, all in which to get stored and made available for future model evaluation. Together, these APIs form a core of the full submission system. I've also been working with the front team to make sure both flows connect smoothly and user can successfully go through all the functions through the user interface. This system is built with a Flask as a backend, MySQL as our database, and React with Tailwind and Redux on the front end. A lightweighted but powerful system to support API-first workflow. Then I'll briefly talk about the evaluation metrics, although it's already been covered in Angela's presentation. So first, it's a BLUE, which is a bilingual evaluation understudy that checks how many word sequence, or so-called n-gram, in the model output match the reference. It's widely used in the translation and generation task. And the second metric we have now is the BERT score, which uses the embedding from the pre-trained BERT model to compare sentence meaning. And this is especially helpful for languages where the exact token overlap is less meaningful. These metrics are automatically run in the backend once model is submitted through API, and the score will then be updated to the database as well as leaderboard. And here are two snapshots of a current leaderboard. It shows how submitted models are ranked based on BLUE and BERT score evaluation across the benchmark dataset. Right now, the data board includes results of zero-shot model like GPT, Cloud, and Gemini. These results are manually maintained for the presentation, but eventually our API system will allow these rankings to be updated automatically as new models are submitted and evaluated. This static leaderboard serves as a front-end foundation and will be connected to the backend via API that we just discussed. So looking ahead, there are several clear action items for improving the leaderboard system. First, I'll be working on finalizing API structure and ensuring that the evaluation logic runs smoothly end-to-end. We're also planning to merge the static leaderboard display with the backend infrastructure, so results can be pulled directly. Supporting different formats of schema types is another important goal we aim to, especially as we plan to expand to diverse text types. And looking ahead a bit further, we're considering community features like posting automatic shout in Slack or maybe linking when someone submits a tough performing model. So to wrap up everything, this project has been a great opportunity to contribute to Anno's mission of making AI more accessible and transparent. By automating the submission process, we're removing frictions for developers, reducing manual overhead, and setting the foundation for a more scalable system. Even though this is still an early stage system, I learned a lot from working through the process, and it's really excited to see how things could evolve in the future. So this is all of my presentation, and thank you.